Alrighty, hello, how are we today? So yesterday was one-step equations with integers. Okay, today we are going to take it a step further. Okay, we're going to use our other rational numbers of decimals and fractions. Now remember, an equation is like saying the same thing instead of a variable of a question mark. Okay, you have seen problems such as 4 plus question mark equals 12. You saw those all through your elementary days. So you've been doing algebra for some time. Okay, so let's go through, and you're eventually going to have to do two-step equations that have our decimals and fractions in them. So it's something we're always going to have. So we want to make sure that you are ready to go for when we get to the rest of it. Okay, this is our third set of notes of this unit. It's our third unit, so that means eventually you're going to have another unit test. So that's why it's important to stay organized with your notes. Okay, if you printed out the notes, otherwise this is what our notes are going to be about. So our first one we want to talk about, we want to complete this sentence. We always talk about algebra and equations being like a scale. Remember the balance scales that you see in science class. Okay, an equation is like a balanced scale because you have to, keep both sides of the equal sign balanced. Okay, that's why whatever we do to one side of the equal sign, we have to do to the other side. Okay, so for a quick review, how we would solve and check an equation, we have y minus 7 equals 13. Okay, so if you're doing this the vertical way, you want to do the opposite or inverse operation of subtraction is addition. Okay, if you're writing this vertically, you would put it as that's the same way. Whichever way you're preferring to do your work to show that we know that these cancel out because they have 0 pairs. Then we're only left with a y equals some number. Okay, well, we have different signs. If I owe you $13 and only give you 7, I still owe you more money, right? I still owe you $6 more. Okay, so that is how we solve and get our solution. But now we have to check our work by taking what we got for y and plugging 6 in for y. Starting with my regular equation, I am now putting a -6 instead of a y. I'm putting the rest of our information. Okay, but remember, we can't just subtract. We have to use the integer rules. We have to have an addition problem. So that's why we add the opposite. So then I can see I have 2 negatives. So I'm going to add them together because we are decreasing twice. So it really is just a -13 equals a -13. My answer is correct. Okay, now remember, you can pause this all you need to. All right, we have 2 compare and contrast that we are going to do. But with these, they are going to be a decimal problem and a fraction problem. So we want to look, what do we have going on here? Well, they both have the same terms. of an x, negative 5 4/10, and 3 1/10. That's the same. Okay, we are going to solve them both and check them. Remember, to solve, we're trying to get our variable to be by itself. We want to isolate it. So what's different over here? This one is written as an addition. And the other one is written as a subtraction. Okay. Both of them, we yes do need to solve. So I'm going to rewrite them as they are so that I can actually solve the problem. But because they have different operations, I'm going to have to do a little bit different work. Okay. So remember we talked about using the inverse operations. So here if I said what's the inverse of addition, we would say subtraction. Remember we have a negative number. So that kind of changes things because now we have to add the opposite. So I am really adding a positive. So on both sides of the equal sign, to keep it balanced, okay, these now cancel. I'm left with my x, and then I'm adding these two numbers together to get that x is 8.5. Okay, so let's see what's different with the other one. Okay, the inverse of subtraction is addition. So we are wanting to add a negative on the other side of our equal sign. Okay, so add a negative. Well, now this means we have different signs. Okay, so our rule tells us different signs subtract and keep the sign of the higher value. Well, which is bigger, a 5 or a 3? A 5. So my answer is a negative. Okay, so if I really need to subtract, I need to take my 5 4/10 minus my 3 1/10. That becomes a 3, that becomes a 2. So my answer, solution, we would say, is a negative 2 3/10. Okay. Same terms, but different operations. So it gives you a different answer. All right, so let's see. Let's check our work. Okay, so this one we said 8.5 plus a negative 5 4/10 should equal a 3/10. Okay, so I have different signs because I have a positive 4.5 and a negative 5 4/10. So I actually need to subtract those. So 5 minus 4 is a 1, and 8 minus 5 is a 3 with a decimal in between. And it is positive because this is my higher value, and it's a positive. So yes, it works. All right, let's check my answer for the other one on the right. I am plugging in my negative 2 3/10 minus a negative. And I kind of erase this word so that room. Right, same numbers, different operations. All right, but remember, I have to add my opposite. Some of you call it keep, change. Okay, now I can clearly see that these are different signs and I need to subtract them. So 4 minus 3, because 5 is the higher number, so I would write it with the 5 4/10 on top. So 1, that's a 3, that's where my decimal goes. And we have our correct answers. Okay. Oh, something else they have in common. One-step equation. And if you didn't know, equations are algebra. You are working up your way on your algebra skills. Need to pause this, fill in your notebook with the notes. Okay, so your homework is going to have decimals and fractions on it. Next one I'm going to is a fraction problem with mixed numbers too. Okay, something that they have in common. Well, they don't have the same terms. Okay, but they both have the variable x. Okay. They both are going to need to be solved and checked. They both have fractions and mixed numbers. Let's see, written as addition. Then they are both one-step equations. All right, so let's now get down to the main business. How am I going to solve this? Well, remember, whenever we add fractions, we need common denominators. Okay. So we have to think, what's the number that 4 and 3 have in common? If I was to skip count by my threes, 3, 6, 9, 12, 15, and I skip count by my fours, these are all the multiples. So we're trying to find the least common multiple. Ooh, wait, here's a 12, here's a 12. Okay, so I would have to multiply both of these by 4 and multiply these by 3. And then rewrite my equation. Okay, so that's our LCM. So x plus 8/12 equals a negative 4 and 9/12. Okay, so my next job is to figure out how am I going to get this x by itself. Remember, if we want to isolate it, it's being quarantined all by its own. So subtract our 8/12 on both sides. Okay, just how I like it, vertically. I have my zeros. And then here I see I have a negative and a negative, same signs, add and keep. Okay, so now I just have to add them. So 8 and 9 make 17. Well, that's improper. So improper. How many times can 12 go to 17? One time. So we are going to eventually need to add another 1 to this 4 to make it a 5 and change our 17 to a 5. So 17 minus 12 is 5. If you take a 12 out, there's only 5 left over. Okay, so that's what we're saying our answer should be. Let's look at our other one. Instead of 4 and 3, we have 5 and 10. Well, I know 5 can go into 10 if I multiply it by 2. Okay, so that's easy to find that our LCM equals 10. So we already have x plus 8, 10. That is equal to 3 and 7. Okay, do our inverse operation. Subtract our 8/10 from both sides. Okay, these cancel. I have my x left over, my equal sign. I showed that I'm subtracting on both sides of the equal sign. But if you look, can I take 8 away from 7? No. So I have to do some regrouping. I have to take a 10 out of 10 and put it with the 7/10. And it changes my 3 into a 2. Where did I get 10 out of 10? Well, that's what my denominator is. So this really is a 17 over 10. So 17 minus 8 is 9. Keep our 10 on the bottom, and now I only have a 2 left over. Okay. So now let's check our work. Okay. So I'm taking a negative 5 and 5/12 and adding 8/12 to it. If I still get a negative 4 and 9/12. Okay. Well, I'm not really adding because I have different signs. I have a negative and a positive. So remember our rule, if we have different signs, we're really subtracting. Then we're keeping the sign of the higher value. Well, 5 is greater than a whole number of 1. So I know my answer is going to be a negative. We want to know, though, is it going to be a negative 4 and 9/12? I have to do a little bit of regrouping here. I can't take 8 away from 5, so this becomes a 4. I add 12 to get 17. Okay, so now 17 minus 8, that does give me my 9/12. And I have 4 left over. Bada bing, bada boom, we are good on that side. Let's see if I was still good on the other side. If you notice, both of these also had borrowing. That's something else they had in common. All right, so we said that x was 2 and 9/10. We're going to add 8/10 to that. Does that equal 3 and 7/10? All right, so if we add 8 and 9, that makes it 17/10. That's the answer. Okay, so really we have a 7/10, and we're going to add 1 to this 2 to make it 3. So yes, we would say we have 3 and 7/10 is equal to 3 and 7/10. Okay, and we had to change this because we had 2 and 17/10. We changed it to the 3 and 7/10. Okay. All right, if you need to pause this to finish copying, do so. And then we will go on to the homework. So if you need to, open up your CAMI document. Okay, I have 2 on the back side that I'm going to do with you. I'm going to do 7 and 9. Then you have 8 problems. Well, technically, you have 2 extra questions. So you'll have 10 problems to do on your own. All right, so the first thing I noticed is I have a subtraction problem. Well, what's the inverse and the opposite of subtraction? Addition. So I need to show on both sides of this equal sign. And remember, your teachers are going to be pretty picky that you are showing this on both sides of the equal sign. Okay. Then I have Z is left over. But I notice I have different signs. Okay. So I'm really going to subtract with my larger value on top. And then I have to do some regrouping. So 14 minus 6 is 8, and 8 minus 3 is 5. And it is a higher value is a positive, so I keep a higher value. Okay? And as always, you check your work, especially with using decimals right now. You really want to check your work if you're using decimals and fractions. Okay, so I'm going to replace Z with my 5 and 8/10. I'm going to subtract from it to see if I get a negative number. So remember, we have to add the opposite. So now I see I have different signs. I know my answer is going to be a negative because this is my higher value. But we got to still do the work to find out if it's going to be the correct answer that we want. So minus, I got to do some borrowing again. That becomes 8. 14 minus 8 is 6. Line up our decimals. 8 minus 5 is 3. We have a negative 3 6/10. Yes, my answer works. Okay. If you have any questions about this and why we're doing what we're doing, go ahead and send a message to your teacher if you're not in their live Google Meet that they do. All right, number 9, a fractions problem. All right, first thing first with fractions. Do I have common denominators? No. So I have to get a common denominator. We have to find our least common multiple. 9, 18, 18. That's what I want. I like it. So to get 9 to 18, I have to multiply by 2. So I really have s plus 1 and 2/18 equal to negative 5/18. Well, the inverse of addition is subtraction. Whatever I do to one side, I gotta do to the other side. Okay? The reason why we do that, these now cancel. I'm left with only my variable on one side, isolated by itself. Now here I notice I have 2 negatives. Okay? You see the 2 negative signs. If this was written vertically, you would see this. You might not see 2 negatives until you add the opposite. Okay, so that's how I know, hey, I have 2 negatives, so I need to add these, keep my negative sign. All right, 5 and 2 make 7. Keep our 18 and bring over my whole number. It can't be reduced, so we are good at that point. All that's left is to check our fancy work. Okay, I'm going to use the equation that I wrote with. Okay, so I am going to replace, put 1 and 7/18 where S was. I'm going to add 1 and 2/18 to it. Let's see if we get a negative 5/18. That's all you're doing when you're checking your work. Okay, just replacing that variable with what we found. All right, same signs, add and keep different signs, subtract. Okay, so we're going to subtract. Well, which one's a higher value? They both have a 1, but which one is greater than in the numerator, a 7 or a 2? Well, my 7, it's a negative. So my answer has to be a negative answer, which is good because then that shows me I'm on the right track to finding that I did solve this equation correctly. All right, so then I know I have 18 on the bottom, but I need to figure out my numerator. 7 minus 2 is 5. I am correct. Hey, how about that? All right, you have more problems to finish. Complete those, turn them in. And remember, we're so close to the end of this quarter. Stay on top of getting your work done. And if you have any late assignments, get them completed, especially any quizzes you might have left over.